Okay, picking up again where we left off on question 34, the line y equals negative 3/2 x plus 5 is shown on the graph. So this is the line. Which set of points includes only ordered pairs from the solution set for this line? The difference between this and this is this means less than or equal to. So if you use your shady man, the less than sign tells us we're going to shade below. And the line underneath tells us that if it's on the line, it is included. Okay, so let's look at these points. 0, 1, 2, 3. Yeah, that's a solution. 2, 2. That's on the line, which is included. 5, 1, 2, 3, 4, 5, 1. Nope. Okay, 2, 2. Yes. 5, negative 1. Nope. Okay, 2, 2. Yes. Negative 5, 1, 2, 3, 4, 5, 10. Yeah, I know that's going to be good. Okay, and then 1, 2. Yes. All of these work, so that is your answer. Let's see. This, so let's just double check and make sure. Negative 5, 10, that's the same as that point. 2, 1, yes, that works. 10, negative 5, no, that doesn't work. So we were correct. 35. Which systems of inequalities is represented by the graph shown? Okay, so they both have positive slopes. One of them needs to have the line underneath, and this is where it's starting at. Okay, so this one, it's starting at 4, so y-intercept of 4 needs to be a dotted line, which again, shady man, if it's a dotted line, that means it's not included, so it doesn't have the line. Okay, so 4 shouldn't have the line. Nope. 4 shouldn't have the line. That works. 4 shouldn't have the line. Nope. 4 shouldn't have the line. Okay, we already knocked off 2 of them. This one, the y-intercept's at negative 5, and it should have the line. So negative 5, line, negative 5, line. The only difference between those is a slope of 2 and 1/2 compared to 5/3 and 3/5. This is where that green, that go part of your highlighting can really help you. So what we need to look at is the slope. So am I going, for this 4, am I going up 1 over 2, or am I going up 3 over 5? Up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. That's close, but that's not hitting the line any more than these farther points. So let's see if 3/5 matches better. Up 1, 2, 3, 1, 2, 3, 4, 5. That looks perfect to me. 1, 2, 3, 1, 2, 3, 4, 5. Yes, that falls right there on the line, so this is your answer. Which two equations will form a system whose solution is the ordered pair 2, 5? Okay, so that means system is 2 or more equations, so we're going to have to use 2 of them. So let's try 1 and 2 first. This one and this one. Let's plug them in our calculator. So x plus 5 and 2x plus 1. No, 2x plus 1. So let's go to the table. Is the solution at 2, 5? At 2, we have a 7 and a 5. That is not matching, so 1 and 2 does not work. So let's try 1 and 3. So we've got that 1 still, so 4x minus 3. No, that still doesn't work. Okay, so it's not that one. So let's try 2 and 3. That second equation is 2x plus 1. And then we have 4x minus 3. So when I plug those in and I look at it, 2 matches with 5 and 5. So that is the solution for numbers 2 and 3. 37. Which situation is best represented by this system? 45x plus 10 and y equals 35x plus 60. All right, so let's read them. Colby has $10 in the bank and plans to add, so plus, $45 each month. Each tells us it goes with our X, so 45X. So that matches. Emily has $60 more than Colby. I don't see any eaches. I don't see anything like that. It is not A. Leah and Cody both need to have their cars repaired. To have them repaired, Leah will pay $35 per, so 35X, plus a $60 towing fee. Cody will pay $10 per, plus a $45 towing fee. So this one matches right here, but this, the per is with the 10, and we need it with the 45. Cameron is a designer who makes $45 per hour and receives a $10 travel allowance, so plus 10. Tony is a financial consultant who gets $60 expense allowance and earns $35 per hour. The per is with the 35, the per is with the 45. That is what we want. Joshua decides to use substitution to solve this system. So we need to look to see what variable is by itself. The y. The y is by itself. So the y is by itself. And we can replace it with this whole thing. So you are going to either wormhole it or jack in the box or whatever it is that your teacher taught you. So we're going to replace this circle with this circle. So we still want 3x. None of those have 3x except for C. Another way you could eliminate is you have to get an equation with one variable. That is how you could eliminate A and you could eliminate B. Because there's an X, there's a Y. There's an X, there's a Y. So it had to be either this one or this one. And I don't know how this is getting so small. 39. Marixa wants to solve the system of equations by using linear combination. What should she multiply the first equation by if she wants to eliminate the y terms? So we want to eliminate this 3y. So to eliminate a 3y, you have to have a negative 3y. There's nothing in front of it, so we need to multiply by a negative 3. Y, if you wanted to justify, to cancel a 3y. Okay, for the summer, Josh plans to wash cars for his neighbors. Well, he will earn $8 for each car that he washes. So y equals 8x. We've got an equation. If he estimates that he will wash between 10 and 15 cars, what are the possible amounts for E, the money that Josh will earn washing cars? First, let's ask ourselves, is this discrete, meaning things that we count, or is this continuous, things that we measure? Do you count cars or do you measure cars? You count them. They're not continuous data, so it's discrete, okay? So we can automatically eliminate anything with these symbols. So it can't be B, it can't be D. So we've got an equation, and it wants to know the money that would match up if it's between 10 and 15 cars. So if I plug this in my calculator, we have y equals 8x. At 10 cars, we're making 80. Then you could do 11 cars. That's 88. 12, 96, 13, 14, and 15 cars. So the answer is A. Which is the best estimate for the solution of the system represented on the graph shown? As you're just extending these lines. If you wanted to actually calculate your slope, you can, but why make it more difficult on yourself? So here's a point, so I'm going down 1 over 2, down 1 over 2. So I was just a little bit off, but pretty dang close. Here, I'm going up 1 over 1, up 1 over 1, up 1 over 1. So they don't exactly intersect, but it's somewhere around in here. So let's compare these points to see which one's closest. 8, 4. That is nowhere close to this area. 9, 1. 9, 1. Nowhere close. 10, 5. That's way too high. 11, 3. Yeah, that's almost right there. What is the domain and range of the function shown below? Okay, so is this discrete or continuous? It's continuous because it's connected. So we're going to be using these symbols. Robot dealer. Ask yourself. And then we also have Dr. XY. So domain means X. So we're dealing with the X variable. And domain is left to right. So the left part of this graph is at -4. And I'm not going to put the line underneath because it's an open circle. The right side of the graph is at 2. And this time I do put the line because it's a closed circle. Range, robot, is bottom to top. The bottom of this graph is at -4. I'm not going to put the line underneath because it's open. The top of this graph is at 4. And I am going to put the line underneath. Remember, you're not always using the circles. This is up here at the very top. You can't cut anything off. Alright, given this equation, they gave us an equation. Anytime that happens, put it in your calculator. So negative x minus 3 squared plus 25. And they want to know what the vertex is. So this is where you look for your pairs. Okay, so there's some pairs. 21, 21, 24, 24. So right in the middle is 325. Which I also could have gotten from vertex form. This is the x value, the 3. This is the y value. This is our h and our k that we're learning about right now. Okay, the axis of symmetry always starts with x equals, and it's x equals 3. Okay, what is the vertex or max or minimum? Is the vertex a max or min? I'm going to look at the graph to see. I can't see the whole thing, but I can tell it's going up and it's coming back down. So if it's going up, it has a maximum. You could also look at the table. That vertex point, that 25, is that the largest number or the smallest number that you see? It's the largest, it's a max. Does the graph open up or down? If it is a maximum, that means the vertex is up here, it's opening down. The arrows, if you were to draw the graph, would be facing down. What are the x-intercepts? So it's somewhere around in here. Let's look for those zeros on our table. So there's one at -2, 0. And we need its pair at 8, 0. What is the y-intercept? So now we want a 0 in the x, and it's right there at 0, 16. So use your equations in your calculator. When graphed, what function would appear to be shifted 5 units down from the graph? I had over. Oh, I should have written that the other way, but that's okay. I had over, okay? 5 units down. So we're wanting to make a vertical change. So that means vertical means up or down. So it's exactly what you think, and it needs to be outside the parentheses. So this is -5 outside the parentheses. So we're making this change to this +3. So our equation would be f of x equals x squared minus 2. Okay, last problem, question 45, is again talking about transformation. So we're going to use this I had over. Okay, how is it changed if we're taking x squared and going to x plus 7? The 7 is inside parentheses, so we know it's going to be horizontal, which is left or right. Okay, and it's going to be the opposite of what you think. So plus 7 actually makes you go left 7. If you cannot tell, if you don't know your equations, we are given equations. Plug in your calculator. So x squared, and it's also giving us x plus 7 squared. Let's look at the graph. It was here. Now it's there. It is going left 7. Beautiful. Make sure you show all of your work so that way you can turn it in.